Section 4.1, the greatest common factor, GCF. The greatest common factor is the largest possible integer or variable, sometimes it can be both, that can be factored out or be divided into in a list of numbers or a polynomial. Find the GCF for 45 and 75. Now we'll approach this right now in the way I first showed you in the first half of the semester, where you do the prime factorization of a number. 45 is basically 9 times 5, but 9 is 3 times 3, so therefore the prime factors of 45 is 3 times 3 times 5. 75 is 15 times 3, or 25 times 3, if you will. Let's say I chose 25 times 3. Well, 25 is 5 times 5, so therefore 75 is 3 times 5 times 5. Now, after you've done that, you go back and determine what do they share in common at the same time. And you basically are going to circle that off. As you can see here, they both share a 3 and they both share a 5. So that means I can factor a 3 and a 5 from the both of them. And if I multiply those two together, that gives me 15. So basically the GCF for the numbers 45 and 75 is 15, because 15 is the greatest number that divides into both of them evenly. The variables, y to the 4th, y to the 5th, and y to the 6th. Remember, y to the 4th and y to the 5th and y to the 6th is all shorthand. So y to the 4th is shorthand for 4 y's, y to the 5th is shorthand for 5 y's, and y to the 6th is shorthand for 6 y's. Once again, go back and look at what they have in common all at the same time. Okay, they have a y in common. I can take out a y. They have one more y in common, so I can take out 2 y's. They have one more y in common, so I can take out 3 y's. And they have one more y in common, which I can take out 4 y's. So if I do so, therefore the GCF for y to the 4th, y to the 5th, and y to the 6th is y to the 4th, because they all have 4 y's in common. Now this is a very, very helpful note here, and it's sort of a shortcut when it comes to variables, and this can only be done for the variables. When it comes to variables, the GCF will be the smallest exponent amongst the whole group. Basically, this means is you're looking at all of the exponents as a whole, but you're looking for the term that has the smallest exponent, because that is the GCF for all of them. Please remember this note. It'll be very helpful in the future. Find the GCF for 6a to the 3rd b plus 3a to the 3rd b squared plus 9a to the 2nd b to the 4th. What would be the GCF? Let's start with the numbers first, 6, 3, and 9. Well, the GCF for 6, 3, and 9 is 3. Why? Because 3 is the greatest number that divides them all evenly. Okay? Let's move on to the variables. The first term has 3 a's, the second term has 3 a's, and the third term has 2 a's. Remember, when it comes to the variables, the smallest exponent is the GCF of the entire group. So 2 is the smallest exponent of the a's, therefore I can only take out a to the 2nd. Let's move on to the b's. The first term has 1 b, the second term has 2 b's, and the third term has 4 b's. Once again, the smallest exponent is the GCF of the entire group. So therefore I can only take out 1 b, so altogether the GCF is 3a to the 2nd b. Now what do you do when you factor out the GCF? Well, you want to know what remains once you factor the GCF out. So when you factor the GCF out, you'll be using it to determine what remains by dividing it into the original expression or equation, what have you. So that looks like this. You're going to divide each term individually by the GCF, because that's what you've taken out. So once you've taken it out, you're going to see what remains on the inside of the parenthesis, which is doing simple division and subtraction of exponents. 6 divided by 3 is 2. 2a's from 3a leaves a. 1b from 1b leaves no b's. Plus 3 divided by 3 is 1. 2a's from 3a leaves a. 1b from 2b's leaves b. Plus 9 divided by 3 is 3. 2a's from 2a leaves no a's. And 1b from 4b leaves 3b's. Remember, you can check your answer by distributing this together or multiplying. And if it comes back up to the original expression, assuming you did the multiplication and the addition of the exponents correctly, you should come up with exactly what we started with. Factor by grouping. Factor by grouping is another technique we try to use to see if we can factor an expression with 4 terms. Emphasis on 4 terms. See the steps below. Step 1. Group the terms in 2 groups so that each group has a common factor. Step 2. Factor out the GCF for each group. Step 3. If there is a common binomial factor, factor it out. Step 4. If not, rearrange the terms and try these steps again. Now, in this course, there is no such thing as a step 4. These questions are meant to factor out perfectly, so therefore you will always have an answer. You will always be doing step 1 through 3. First example, here you have 4 terms. 28x to the third, negative 7x squared, positive 12x, negative 3. Step 1 in the process says to group the terms together in pairs of 2. So the first 2 are grouped together, the last 2 are grouped together. Please keep in mind that the sign that's directly in the middle is going to be left on the outside of the parenthesis. Step 2, factor out the GCF of each section. So let's start with the first 2 terms. 28x to the third and 7x to the second has a GCF of 7x to the second. Why? Because 7 is the GCF for 28 and 7, and x squared is the GCF for x to the second and x to the third. Remember, when you take your GCF out, to divide by it because you want to know what remains on the inside. So if you do so, 28 divided by 7 leaves 4, and 2x's from 3x's leaves 1x. Negative 7 divided by 7 is 1, and 2x's from 2x's leaves no x's. Okay, bring the sign in the middle down. Now, what's the GCF for the second pair? Well, that would be 3, because 3 is the greatest number that divides into 12 and 3 evenly. We will not be taking out any x's because there's not enough on both terms to take out an x. Okay, so if I divide those 2 terms by the GCF of 3, what remains? 4x minus 1, because 12 divided by 3 is 4. Bring the x down, and 3 divided by 3 is 1. Step 3 says if there's a common binomial factor in common, which there is a common binomial factor. That common binomial factor here, as you can see, is the 4x minus 1 and this 4x minus 1. So we're going to basically factor them both out. And by doing so, leaves us with 7x to the second plus 3 that has to be combined together. And this is how we factor by grouping. Now again, if you wanted to check your answer, all you would need to do is apply the FOIL method here, and assuming you multiply everything correctly, then you will come up with the same expression that we started with. Here we have another example. 4 terms, 2xy, positive 5y to the second, negative 4x, negative 10y. Step 1, group the terms, pairs of 2. The first 2 are grouped together, the last 2 are grouped together, once again with the sign in the middle being on the outside. Step 2, factor out the GCF of each section, starting with the first 2 terms. The GCF for those 2 terms is y. Why is it y? Because that is the only thing that they have in common. They do not have a number in common other than 1, so therefore technically there's no need to factor out a 1. They don't have enough x's in common to take out any x's, so therefore we can only take out the y. Now if I take out the y, what remains? 2x plus 5y. Bring your sign in the middle down. What would be the GCF for the last two? That would be 2. No x's and no y's. They do not have enough in common for us to take out any x's or y's. So if I factor out the 2, what remains? 2x minus, but actually is plus 5y. And again, step 3 says, if there's a common binomial factor, then factor that out. And what remains is put together, which is the y minus 2. Section 4.2, factoring trinomials in the form of x squared plus bx plus c. This is called the BC method. Okay. In this section, we'll be learning how to factor trinomials in the x squared plus bx plus c, the BC method, meaning the coefficient of the x squared must not be bigger than 1. Okay. What does that mean? That means that the number that is right here cannot be bigger than 1 in order to use the BC method. See the format below and the example on the next slide. So x squared plus bx plus c is one of the easier ways to factor because the BC method allows you to go ahead and break down your parentheses, as you can see over here. Okay, so whatever the variable is that you're dealing with in the expression at the time, all you would need to do is put one of them here and one of them here. Now what is important is what are the signs that are going to be here and going to be here. We'll discuss this a little bit more as we proceed. Okay, but it's known as these two numbers will give us the product of C, meaning that these two numbers when multiplied must give us the value of C, which is right here. Okay, and their sums must give you B. Okay, that means that when you add those same two numbers up, they must give you this term right here. Okay, so the BC method is known as the product of C to give you a sum of B. First example, x to the second, positive 12x, positive 20. This is the BC method. Again, why? Because the coefficient here is not bigger than 1. So we can go ahead and apply the BC method. All right, so if we apply the BC method, that means we can go ahead and do this. Now what we're looking for here is what are the numbers and what are their signs. Okay. Now what I like to usually do is to the side somewhere, I like to create a chart. One side being for the product of C and one side being for the sum of B. So on the product side, I write down all the ways I can multiply two numbers that will give me a positive 20. And on the right hand side, I will add those same two numbers up together to see which one will give me 12. So as you can see, I've listed about 6 ways that you can multiply two numbers to give you a positive 20. And on the right hand side, I added those same 6 ways up to see which one will give me positive 12. If you take a quick glance, you can see that the numbers that I'm going to be using here to solve this question would be a positive 2 and a positive 10, because positive 2 times positive 10 is positive 20, and positive 2 and positive 10 when added together will give me 12. Here's another example. This is the BC method once again, so I can go ahead and break down my parentheses. And again, I create a little chart. You don't have to do this if you don't prefer. Some of us can do this mentally, but for those who don't like that way of doing things, you can easily write it out. Okay, so I've listed the ways of getting a positive 50 when multiplying two numbers. And I've added those same ways together to see which one will give me negative 27. If you take a quick glance, you see the numbers are going to be a negative 2 and a negative 25. Here's another example of the BC method. So we can go ahead and break our parentheses down. Again, I create myself a little chart here. I'm trying to find two numbers will multiply, will give me negative 36. But if I add those same two numbers together, will give me a positive 5. If you take a quick glance at what I've listed here, you can see that the numbers that I'm going to use are going to be negative 4 and a positive 9. Another example, BC method. I can break down my parentheses, create myself a little chart, list all the possible ways of multiplying two numbers that will give me negative 40, and if I add those same two numbers together, will give me negative 3. If you take a glance at all my possibilities, you can see that the one I'm going to choose is going to be positive 5 and a negative 8.